formula for a circle comes from the distance formula. And if we assume that h and k are the points that represent the center of our circle, and then x and y represents any point on the circle, we can actually use the distance formula to see where the formula for the equation of a circle comes from. What I'm going to do is use the distance formula, and since the distance from hk to xy is actually the radius length, then I'm going to say, instead of distance, where distance equals, distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Instead, we're going to use the radius equals, and then as our x2 y2 pair, this first set of numbers, I'm going to use just the x and the y. So I'll write x, and then since h is my other x value, I'll use that as x1. So x minus h squared plus, and then I'll repeat the same thing with the y values. We'll do, and if it helps, I can do x2 y2 here and x1 y1 here so that we can follow how we're mapping this into the formula. So for the second pair, it'll be y minus k, and then I'm going to square that quantity. Now, this is actually the distance formula with all of those variables put in. But if I were to square both sides of this equation, I would cancel this whole radical by squaring, and I would end up with r squared equals x minus h squared plus y minus k squared. That's where the formula for the radius and center of a circle come from. And you can see that r squared is simply the radius value, but we have to square it to fit it into this standard formula. And then we just need to remember that since the center is hk, positive h, positive k, and in the equation we have subtracted them, we will need to always remember to change the signs for h and k when we are working with an equation formula. And here is an example. So let's say that I am given this formula. 25 equals x minus 4 squared plus y plus 2 squared. Well, in order for me to put this or map it back into the standard format, then I might do this. I might say, well, this is a perfect square, so that would be 5 squared. And over here, I might just ask myself what this would have to be if this were negative h. I want the opposite of this, so it would be actually x minus a 4. So 4 is actually what's being subtracted. And then over here it would be y minus, and it would have to be negative 2 in order for it to become positive here. So you have to think about, what am I subtracting in order to get this result? And so I'm getting y minus negative 2. That helps me when I make that little step to see that the radius is going to be 5 because this is r squared, and then the center value is just hk, and I've just identified that h is 4 and k is negative 2. So whatever the sign is for the h and the k, just change it to pull it out and use it as the center value. The other thing that we want to be able to do is be given, that's example 1. We'll do another example here, example 2. And for this one, we'll say, let's be given a center value of 3, negative 1, and a radius of 2. Then we need to be able to write the equation for this. So, and I'm going to reverse this and put it in the opposite direction to show you that it's okay either way. So this would be x minus 3 squared plus y plus 1, remembering that I have to do the opposite of whatever the sign is, equals 2 squared. And that's going to give me my equation, which, if I simplify one more step, x minus 3 squared plus y plus 1 squared equals 4. And there's my equation of a circle. So that shows us how to go forwards and backwards.